So when you guys left, we had just done a bunch of stuff with the quadratic formula. Quick reminder, those are where A, B, and C come from. And we had done the discriminant, which is this part. And I remember how the discriminant, if it was positive, you get 2 answers. If it was negative, you don't get any answers because you're square rooting on negative. Just ringing a bell? The weirdest one is if it equals 0. Let me explain that a little bit more. If this part equals 0, then do you get square root of 0 as just 0? And if you add or subtract 0 to something, it doesn't even do anything if you add or subtract 0, right? So if you have a 0, then this whole part drops out. And you're left with negative b over 2a. Do you have a short-term memory? We had that formula before this year. And it was for the vertex. Negative b over 2a. Does that ring a bell? Okay. So this formula is intense. Quadratic formula's got the vertex formula in it. Right there. Negative b over 2a. And it's got this thing called the discriminant in it. The b squared minus 4ac thing. And that tells you how many solutions you're going to get. And then you actually have to use the whole formula, like putting in all the numbers, to get the solutions. And they have 4 names. They're called roots. That's the weird one nobody ever remembers. But there's 3 other names. Can you name one? The answers to this are called the roots, the zeros. Very good. Anybody else name one? Solutions. Excellent. But then you skipped one that a lot of people might have a chance at. It has to do with the graph of it. X what's? X-intercepts. Yes, nice teamwork there. Okay. Those 4 names for the answers to these. You're finding the roots, the zeros, the solutions, and the x-intercepts. And sometimes there aren't any because they're imaginary. That's if there's a negative underneath the square root. Okay. All right. So we're going to take a second right here at this point and grade that quiz that we took yesterday. So I'm going to pass them back, but you're not going to grade your own. You're going to grade somebody else's. I'm going to pause for a minute while we get done grading. So we're done with that part, and the quizzes are graded. I am just curious, how many of you got an 8, 9, or a 10? Raise your hand if you did. Okay, that's definitely the majority of the class, so that's a good start. So, what are we doing now? I want to make sure you get what these look like in the real world. If you throw a ball up in the air, I want you to just imagine for a moment, cell phones away please, that this would be the path of the ball. Do you get that the ball, in this case, is going up, stops going up eventually, gets to its highest point, and then turns around and goes back down again? Isn't that pretty accurate for what a ball would do if you threw it in the air? It'll go up for a while and then stops, and then it goes back down. All right, so this is the height, and this is time. This is one of the hardest things to get across to you. That blue dot there, that is a when. That's not a where. The ball is on the ground at a certain time. Just so you know, it's really hard to keep the ball in the air more than like 3 seconds. 3 is like the most almost anybody in here could do. If you're really, really, really good at baseball, maybe you could keep it up for 3.5 or maybe 4 seconds. It's really hard to keep the ball in the air that long because gravity, right? Okay, so that is a time. That is not how far the ball was from you. That is not what that is. That's a time. 1 second, 2 seconds, 3 seconds. Okay? Next is this spot has a name. In parabola land, that's called the what? Vertex. And we used a formula for that. X equals, do you remember it? Hint, it's not the quadratic formula. Negative? B over 2x. Yes. That's the vertex formula. Everybody write that down. This is the part where you're taking notes because I don't think many of you remembered that. So write this down. Because this is the new stuff for today is when we give you a real world situation, you got to go, well, which tool do I use? What is the quadratic formula for? It's for the x-intercepts. Do you get how that's an x-intercept? That's the time the ball hit the ground. You get that from x equals negative b plus or minus square root b squared minus 4ac all over 2a. That is the formula that gives you the x-intercept. Does it ring a bell? You see how we tie in what we learned for the last couple days? That's how you use that quadratic formula. And that's actually getting you the time that the ball hits the ground. You can do that. We actually have a lab. There's not too many math classes that have a lab, but we have one called Honors Pre-Calc. And if you take Honors Pre-Calc, that's the kind of thing we do. We'll take the kids out to the parking lot. Everybody gets a ball. You throw the ball up. You record it with your iPad. And then you're able to tell exactly from the second it leaves your hand until the second it hits the ground how long the ball was in the air. And then we're able to use that time the ball was in the air, right? This is the time down here. We're able to use that to figure out how high you threw the ball. Isn't that kind of cool? You can actually calculate the vertex then once you know how long the ball was in the air. You can stick that in this equation. It's kind of complicated, but it's Honors Pre-Calc. Can't expect it to be a 2-second explanation. But, okay, so what do you have to know how to do? Well, number one thing is you have to be able to write an equation. So everybody get this page of the notes. We've already practiced this. We just had a quiz on it like a couple minutes ago. I don't want to redo these. This is A, this is B, and this is C, and you can stick them in there. And if you want just the discriminant, that's just this part here. So that's enough review. If you were going to do the discriminant, you just do b squared minus 4ac. And it would tell you how many solutions you're going to get. Okay, now here's this quadratic motion, and that's the new thing for today. Imagine that Zoe throws a ball in the air. The height of the ball after time t is greater than 0. How come the ball doesn't start on the ground? Well, because in the real world, when she lets go of a ball that she's throwing, is the ball on the ground? No. It would be up a certain number of feet. And we're using feet for this graph, so that's 10 feet. Do you get that she's not 10 feet tall, and therefore the ball's going to be more like, I don't know, a little less than halfway. So that's like 4 feet off the ground is when maybe she threw it underhand and she let it go at about 4 feet. That right there, everybody label this, start height. That's the starting height. The ball started about 4 feet off the ground. Because when she let go of it, that's the moment you start your little experiment. This is called, starts with a V, the vertex. And it's also, in the real world, you just say that's the highest that the ball went. Okay? And last but not least, this is not how far the ball is from Zoe. What is that? Do you have a short-term memory? Just told you a second ago. What is that? That is the time that the ball hit the ground. So its height is 0 right there because it just hit the ground. At what time? Well, it looks like a little more than 2 seconds. So she threw it up in the air and it landed a little more than 2 seconds later. Is all this making sense to you? Okay. So, first question is super simple. How high above the ground is the ball when Zoe throws it? That's right there, and it looked like it's about 4 feet. Part of the graph, that part. It's also called the y-intercept. When does the ball hit the ground? Well, it looks like a little more than 2, so I'm going to say like 2.1 seconds. It doesn't have good units there, so I'm going to, well, actually, you could argue that it does. But 2.1 is close enough. What part of the graph shows this information? Well, the other one was a y-intercept. What's this one? X-intercept. Okay. Quadratic motion graphs again. It's got the same exact graph. How high does the ball travel? Oh, that's pretty easy. Look. Can you see it from the graph? How high did it go? 20. What part of the graph shows this? It's got a name, starts with a V. vertex. Okay. When does the ball reach the maximum height? Ooh. When? That's like the time. You can follow it back down here and say, oh, it was at time 1. At what time does the ball reach a height of 10 feet? It's a trick question. At what time does it hit 10 feet? Jack, why is it a trick question? The time it hits 10 feet. Would you agree it hits 10 feet right there? Then why is it a trick question? What? It hits it twice. Do you get that this ball went higher than 10 feet? So it hits 10 feet on the way up and on the way down. All right. When does it reach the maximum height? I already had that one, sorry. Which part of the graph shows this information? I would just say that part. That's where it hits 10. Okay. Now, this is kind of cool. If you tell me the numbers, I can write an equation for it. Let me show you how easy it is. On Earth, we're going to use this for gravity. Why is it negative? Because we need an upside down parabola. Do you remember that deal? If you have a negative in front, it makes the parabola be upside down. And you would never throw a ball up and have it do this. It would be up there forever. So it's like this. So it's a negative 16. That's just gravity. And we're just always going to use negative 16 when we're doing it in feet. Then the velocity, that's the speed you're throwing it at. Fancy word for speed. 37 feet per second. It just goes right here. 37. And last but not least is how high off the ground are you when you threw it? It says 5 feet. It goes there. Now we're not leaving yet. Very soon though. What if I gave you a different equation, and this time it's on the moon? Would it have more gravity or less? Less. Plus 7t plus 2. We're on the moon, so it's got less gravity. Plus 7t, what does that do? Come on, learn it from the other one. 7 tells you something. It's the velocity. That's how fast you threw the ball. And what's his last number? Starting height. You only started 2 feet off the ground. They must have been a really short person, or maybe they were kicking the ball or something. Okay, so this is the start height. This is the velocity, and that's the gravity. And it'll almost always be 16 because that's just a standard number we use for the gravitational constant. Okay, lunchtime. Okay, so we're back from lunch, and there's really just one thing left that I need to teach you. Everybody write this out. Y equals negative 16 t squared plus 2t plus 1. So the first part I've already taught you is how high was this off the ground when they started throwing the ball? 1. Yep, that's always found here. Okay, so that's how high it was when they started. How fast did they throw the ball? 2. Good. Now, the only thing I haven't told you is, what if they say, where is the ball after 1 second? Well, there's only 2 places left. You could either put in something in t, or you could put in something in y, which is also sometimes called like f of x, or it's sometimes called height right there, because that's what it is. Or h of t. Doesn't that sort of look like a shortened, the word height, except shortened? Okay, so if I give you a height, you put it there, and then it's a quadratic. How are you supposed to solve quadratics? With the quadratic formula. If I give you a time, It's even easier. You just stick it here and here, and then this all just multiplies out with a calculator and you get your answer. All right, so let's talk about that. Do you agree that if I give you a time, it's pretty obvious where to put it? It's where t is, okay? So I'm going to give you a time of 0. So put in 0 right here and here. And do you get these parts would all like cancel out because timesing by 0 means them just disappear. And so what's the answer? Yeah, height would be 1 at time of 0. Doesn't that make sense? At time 0, height is supposed to be 1. So yay, it actually works. What if I said, though, I want to know where it is half of a second after they let it go? Like they released it 1/2 of a second. Well, then you'd put in time is half a second. Put in a 0.5. How would you do that? Well, you'd use a calculator and you'd figure out what all this comes up to. You know, with a calculator, it wouldn't be that hard to go 0.5 squared, times it by -16, and then add half, or 2 times a half, plus 1, and then you'd have your height. Okay, so if they give you a time, you just stick it in for t. And then this is just a calculator problem. And yes, you can totally use your calculators / iPads. All right. So one last one that's a little less messy. H of t equals -16. It'll pretty much always be -16 because we're on Earth. Plus 3t plus 2. And what if I say time is 4? Well, then just put a 4 in. I'll give you a hint. Usually if it's too big of a time, it's just sitting on the ground. Do you get the ball has gone up, come back down, and it stopped at on the ground again? So usually your height ends up being, you know, kind of like messed up if you go too long. But if I said the height was 4, then I'd put the 4 here. And then a lot of people, just because it's a word problem, they're like, I have no idea what to do. But we just had problems like this. Do you get you have to subtract 4 from both sides, and then you'll say 0 equals... Kennedy, can you shut that door, please? And look, do you know how to solve that? It's called the quadratic formula. What's A? Come on, what's A? -16, what's B? 3, what's C? -2. And you just put that in the quadratic formula. Okay, so there's only 2 ways these problems end. They either give you a t, and if so, you stick it here and here, and you just use your calculator to multiply it all out, and you'll have how high the thing was. Or they tell you how high the thing was, and you got to set it equal to 0 first, and then stick this into x equals -b plus or minus square root b squared minus 4ac all over 2a. And I know they're kind of a pain. That's why this quiz only has 6 questions on it, because it's kind of a pain to stick those in. All right, so let's open up the Schoology quiz. Everybody start that right now, and I'll do the first one with you. Then you'll only have 5 left. One of which you'll stick in a time is something. Stick something in for t. One of them. Oh, okay, I got to open up the... It's open for me. Wish they wouldn't even have this setting. It's like, one of the settings is disable. How do we do that? All right. It is enabled, and I know you guys like it when I show you what the correct answers are. So to do that, though, I got to give 2 times by average score, because otherwise some kids will just put in crap answers, see what the answers are. So you'll get an average. If you want to take it twice, you can, but you'll get the average of the 2 scores. All right, there, it's open now. Amelia, would you read me number 1? Okay, cool. And what do they want to know about it?
The initial height of the ball is blank feet and the velocity of the ball is.
Initial height, hold on. What is the initial height, you guys? 2. That's the initial height. You just grab it out right out of the equation. Okay, and then what's the other question? It's probably the velocity. And if anybody else knows how to read the equation, I bet you see it sitting there, Ian. What is it? 50. So the first one's pretty easy. It's just asking you to take an equation like this and then say, what's this and what's that? Okay. Number 2. Mallory, could you read number 2, please?
Negative 16t squared plus 32t plus 1. And then it asks how high is the ball after 1 second.
Okay. Did they tell me the height? Nope. It's really common to think that. They did not tell me the height. They want to know the height. What did they tell me? The time. They said the time was what? 1 second. So, where are you going to put the 1 second? In the t. Now, you'll definitely want a calculator to do this. Although, okay, well, timesing by 1 is actually pretty easy. You could probably do this in your head. Negative 16 times 1 is negative 16. 32 times 1 is 32. Negative 16 plus the 32 plus another 1. You could definitely do that one in your head. Okay. All right. Was that the end to question 2, Grace? Or was there a follow-up besides... T is 1. Okay. All right. Then let's go to number 3.
Wait, what's the answer? The second one then? Like,
For number 2?
so there's 1?
Was there only one answer?
You figure it out. You have to put 1.
So, here. I think all you have to do, Grace, is to put in 1 like this and then figure out what the final answer is. I'm not going to say it because I want you to figure it out. Stick in 1 and see what the answer comes out to be. Just let's check it. Did you guys get 17?
Yeah.
Okay, good. Because that's what you get when you put all that in the calculator. Okay, let's move on to number 3. Megan Peterson, would you read it, please?
The side of an object is multiplied ht equals negative 16t squared plus 20t plus 5. When does the ball hit the roof is 10 feet above the ground?
All right, is that a time? No. Is that a height? So then you put it here. And remember me saying you have to set it equal to 0. How do you do that? Subtract 10 from both sides. And then it'll be equal to 0. And then you'll know A and B and C. Now this is the part where you have to have the quadratic formula. I think they may even put it in the problem or somewhere. Is it anywhere? All right, I'll tell you. As I know some kids do have a problem remembering this. Write this down. You'll take negative of whatever the B number is, which in this case is 20, plus or minus square root of B squared minus 4AC all over 2A. And you put in A and B and C, and you can use a calculator, and then you're going to get an answer. By the way, if you ever get an X equals answer that's negative, which sometimes you do, that's negative times that exist in the real world. No. So you don't want to have any negative. If you get 2 answers and one's negative, throw it out because you can't have negative time. Like, at what time does this happen? You can't say negative time. That's like going back in the back to the future. If you could do that, you'd be a multi-gajillionaire. No negative times. Okay, so when you do this, yeah, you'll get 2 times. One's negative, throw it out. It's called an extraneous answer. That's the fancy name for it. All right. Got you started. I think there's only 2 more questions. They're probably either going to have you stick a number in for time or stick a number in for the height. And use your calculator to figure out the answers. Yes? Hold on just a sec. And that's all I got for the video for today.